Hey everyone, this is Daniel with another long form conversation with nice and deep insights about programming from a master programmer. And today my guest is Rúnar Bjarnason. He is a co founder of Unison Computing, which is a programming language specifically designed for distributed systems and for the cloud. And for the Scala audience here on the channel, Rúnar is also one of the co-authors of Functional Programming in Scala, which is famously known in our community as the Red Book. So we discuss a lot in this conversation. We talk about Unison and distributed systems. We talk about Scala functional programming, good principles and good mental models for programmers, and fun in programming or delightful programming. So I hope you'll enjoy this conversation as much as I did, and please enjoy Rúnar Bjarnason. Rúnar, thank you so much for coming.
Thanks for having me.
All right, so I wanted to start with Unison, of course. How's Unison doing?
It's going pretty well. I mean, the it's like a real language now, and like you can make real systems in it and run them on the real internet and have real users and stuff. So that's been really good to see. To see it kind of go from a research prototype to like an actual language that you can use.
What prompted the creation of Unison? I'm curious about the inception process. What got you into creating a language rather than yet another cloud framework?
Well, okay. So Unison is mainly the brainchild of Paul Chusano, who was also my co-author on the Red Book.
Mm-hmm.
And so we knew each other, from way back in the day. We were doing functional programming stuff, together at work, and decided to write a book together. And and then Paul kind of, so we were actually working on a different language called Ermine at a large company here in Boston. And so we got the kind of the language bug,
Mm-hmm.
sort of like the PL bug from there. But Paul had the idea that you could have, a more structured language where the like the code isn't text, so it's an immutable data structure.
Mm-hmm.
And so he did some research into this, and he had kind of like this research prototype, which he then called Unison, and it was like a structured editor and stuff for this structured language. So that's sort of like where it originated. But then, I remember conversations with Paul where, we were talking about how this would be good for, distributed systems. Because so the way that the structure of the language worked was that every term and type in the language had a unique and deterministic hash. So an address sort of in a global address space. And so you could talk about like subterms completely unambiguously. And that naturally lends itself to the fact that you can talk about terms and types unambiguously over a network. So, nodes can completely agree on what the code is and what it means. So instead of, normally you would communicate with like names or like textual addresses or something like that. And you don't really know what code is running at that address, right? But in Unison, you have the hash of the code. And so you know exactly what code is running at that address.
Okay. And could this not have been possible with existing technology? So I was the overarching question that I had in mind was why or how a programming language came to be rather than a framework based on, for example, the JVM. You're obviously a master of Scala, so why not use something like Scala um, to immutably refer to pieces of code over the network? There are frameworks for distributed systems based on Scala, obviously. Uh, during the the time when the Red Book came about, Akka was a big thing, and Akka was particularly well suited for distributed computing. So I was curious um, how a language came to be and how it actually works and what the advantages are compared to something on top of, for example, the JVM or anything else.
Right. Well, the thing is that if you try to do this kind of thing on top of, let's say you try to do this on top of something like Scala, then you end up, working in this sort of reflection space where you'd be talking about, the hashing of like JVM bytecode or Scala
Artifacts.
ASTs or something. Yeah, so like build artifacts essentially. And that just isn't good enough because you're not able to like talk about this sort of like as a first class thing, or maybe it's like two first class. It's just that it's too far removed from like the actual programming. So you end up talking about these things. Uh, like I say, like you can make Lisp do anything, right?
Mm-hmm.
So just add more layers of abstraction, and like we could have done this in like Lisp, right?
Mm-hmm.
But but it becomes very far removed from like the actual programming, the language that you like actually want to work in.
So essentially, you want to
Uh,
call a function over the network without resorting to RPC kind of frameworks and stuff. Just refer to the function as you would locally. Is that the idea?
yes. So essentially, you should be able to just refer to. So in Unison, it's very, very close, like to the sort of the metal of the language, in that when you just use uh, a term in your expression, like in your program, the reference to that term in the actual AST of the language is a hash.
Mm-hmm.
And so you don't have to have like, some data structure in the language that then you have to go and resolve in the language uh, to like determine what the code is. And then at runtime, load the code like through reflection or something.
Mm-hmm. So it's
So none
baked
of
in.
that stuff is happening.
Mm-hmm.
It's baked in. So the hash is actually in the syntax tree of your expression. And the Unison runtime is the thing that's doing all the work of
The
like
resolution and
figuring
the.
out where that
Mm-hmm.
is. Yeah, resolution.
Okay.
Exactly.
Okay.
So, we originally wrote that runtime in Scala. So
Mm. Interesting.
it was essentially a Scala program that you were running, right? It was just like I guess you could call it a DSL,
Mm-hmm.
um, but not like embedded in Scala, but like a language that was with a parser and a compiler written for it in Scala. But we ended up jettisoning the JVM and writing our own runtime. That runtime was written in Haskell.
Okay. So I wanted to ask, what kind of applications is Unison best suited for? What kind of workload? What kind of use case is Unison best for?
That's a good question. I'd say Unison. I mean, Unison is sort of ideally suited for distributed systems,
Mm-hmm.
which, I mean, when you think about it, it's like most modern systems, you know, like even like client server stuff is a distributed system. Even a browser backend system is a distributed system because you have something running in the front end and something in the on the back end, and they're communicating somehow, right?
Okay.
But as it stands, I would say Unison is best suited for like uh, backends where you have some distributed system that you need to run. So something that potentially needs to scale elastically. So it might need to be, might need to have just a few nodes, or you might need to have a lot of nodes, just depending on like the load.
Mm-hmm.
Uh, and so maybe a backend for, a web service. or possibly some kind of ingestion where you have, let's say you have, 1 million devices out in the world and they're all sending data, you know. And so, normally you'd have, I don't know, something like Kafka or Kinesis, or I mean, you'd have something, right, to sort of aggregate this data. But then you'd have to write, you have to write some Scala code or something, some library to like make sense of that data. And so Unison is very well suited for either sitting in between there or coming instead of those systems. So where you can like, have like these sort of wide data streams where you're like getting a lot of
Data
data
packets,
from,
aggregation, processing, that sort of stuff.
yes, exactly. But like where, you might have lots and lots of devices that are all like sending, and then you need to like aggregate those things on the back end and do some kind of analysis on them.
How does the
Uh,
how does the workflow uh, how is the workflow like in Unison compared to the more traditional languages? For example, I'm going to take a use case. For example, in data pipelines, you have Apache Spark. You have Apache Spark, which is built on Scala on the JVM. You deploy Spark to a cluster, which is usually finite. There's Kubernetes where you can more or less elastically give more or less resources to Spark, and then you send a job, and then you may destroy the cluster or unload the job and give space to someone else if they're using the same cluster and stuff. But the workflow
right.
is pretty coarse in the sense that you have to deploy the cluster, you have to build a job, send it to Spark. Spark processes the data, stores it somewhere, then you load the job, and then you terminate your artifact or your usage of the cluster. And maybe you terminate the entire cluster if nobody else is using that. How does that compare to a similar use case in Unison? Am I making a good starting comparison here?
Yeah, I think so. I mean, yeah, but I want you to think a little bit about the Spark use case where like there may be a lot of people involved in this, right? Because like there's like provisioning of the nodes that you want to run on. Somebody is managing that. Like you can have a job of just like managing a Spark cluster. Like setting up Spark clusters like could be somebody's full-time job. Uh,
Okay, so there's the infrastructure bit. That's
there's an infrastructure bit to this. There's personnel involved that when you're trying to get this done, you have to interface with all of those people, or you may not even know that they're there because they're doing their job really well. But the difference in Unison is that you write the code that you want to run. You essentially save the function that you want to run, and that gets compiled sort of live. So there's no like build of
mm-hmm.
your um, of your
Artifact.
program.
Mm-hmm.
Yeah, there's no artifact being produced. You essentially save it. You add it to your code base, which is like a just a database of your code. This is just saying like I want to save it to my like permanently,
Mm-hmm.
and then you run it,
Okay.
and that's it.
Okay.
That's
So
the whole process.
no infra, no
Well, the
build.
infra,
You just write the code
right,
and
right.
hit run.
Yes, you write the code and you hit run. The thing that the why that works is that you get to talk about the actual deployment of the program
Mm-hmm.
in the program itself. And so, for example, we have this hosted service called Unison Cloud, and which now you can actually host yourself as well.
Mm-hmm.
So you can run it on your AWS or whatever.
Okay.
But you basically have this little Unison library, and you create this environment for like where you want to run it. Or you can like use your default environment. So it's basically one line of code to say like I want to run this in Unison Cloud.
Mm-hmm.
And you call a function called deploy. You pass that function, the function you actually want to deploy, and you run it. You run your program that calls that function.
Okay. So you
And
make a
that's
function
it.
called pipeline. You say deploy pipeline and then run. That's it.
Yeah, that's it.
Wow. Okay. I'm gonna try it.
Yeah, I mean, you could try it right now and it would take you 5 minutes.
Okay. And how is the scalability built in? I mean, if you want to provision more or fewer resources to something like that, so if you want to process a large amount of data, and you want to process that large amount of data over a finite period of time, so you have like I don't know 10 terabytes of data, you want to dump them all in I don't know 5 minutes or 10 minutes or whatever, and you need a bunch of nodes to do it. How does that work? Does that work transparently? Can you configure it somehow? Or
Yeah,
am I
it
not
works at
thinking
sort
in
of
it the right
different.
terms?
No, I think you are, but it works in at different levels of transparency. It depends on sort of at what level you want to work at. So, for instance, you could have or we have libraries that talk about like stream processing and stuff, and
Hmm.
then um, you will basically rely on that library to scale your cluster up and down.
Okay.
Uh, you have uh, sort of lower level primitives where you can say, I have this code over here, like I have a function over here, and you pass that function to another function called like remote.fork,
Hmm.
and you give that thing a location. And a location is sort of an abstract thing. It could be a pool of nodes, or you could say, I want to run this not here. So you could basically say, like, I want to run this at the closest possible location that isn't the node I am running on right now. Uh, so there are sort of like these location expressions where you can talk about where you want to run your code at sort of whatever level of granularity you care about. And so provisioning a new node is as simple as calling this function called fork and giving it a location for where you want that node to exist.
That's so interesting. Okay. How have you
Yeah.
seen Unison being used from, I don't know, people or companies? Have you had the chance to, I don't know, talk to companies deploying cloud applications with Unison? How are they using it?
Oh, well, yeah, we've had the privilege of talking to people who are either, wanting to use Unison or who are using Unison. But it's early days for Unison, so I wouldn't say like there are any large companies using it in
Okay.
production like right now. But there are companies who are like developing things for production. Um, but so the kind of use cases that we've seen people like most interested in are things like data ingestion uh, or something like a streaming analysis over some unstructured database. Like say you have a bunch of stuff in AWS somewhere and you want to do some kind of so say you've got some buckets in S3 and there's always data coming in and you want to have some kind of streaming window uh, where you're showing like the current summary of that. So writing a simple little program in Unison over that is very straightforward.
That's
So
very interesting.
that
Hmm.
that's the kind of thing we see people use it for. But I mean, also like we've seen people play with Unison in various ways, and so people are building websites, people are making blogs. Uh, I have, some people have been building games, like
Oh
little
wow, like
console
multiplayer
games.
games and with state management and stuff.
I haven't actually seen anyone make a multiplayer game, but
It
that
seems like a
would-
it seems like a something that would be very well suited.
seems like a slam dunk to me. Yeah. Yeah, I've
Okay.
thought about making like a multi-user dungeon in
Hmm.
Unison. I think that would be really fun.
How I mean, what do you hope to achieve with Unison? What is the kind of metric for success for you with Unison?
I mean, the whole reason that I got involved in Unison is it was sort of out of anger because just like
Okay.
the state of programming. Uh, so when you're working on like a large modern system, you end up spending most of your time doing work that is not programming. You end up spending most of your time like managing some build or,
Infra.
doing some kind of infra work, you're thinking about AWS like a lot more than you need to. And there's like a whole discipline, just like figuring out how to run stuff on AWS. Uh, and programmers hate this, and I certainly hate it. And so I want that to go away. And I really think that the reason why it's such a pain is that the programming languages aren't really capable of talking about that stuff. So programming is still stuck in this very 20th century way of thinking, which is that a program runs on a single OS process on one computer. And if you want your program to run on multiple OS processes on lots of computers, then you need something else. You need something other than programming to like coordinate all that stuff, right?
Hmm.
Um, and and really, I think that I just don't like that. And so I want to be able to talk about that stuff in my programming language because it's programming, right? It's Turing complete. You should be able to talk about anything you want. Uh, and so that's really what Unison is about for me to improve the experience of writing modern software. Because I think that something that's really underrated is just like programmer happiness.
I can
Like
definitely.
yeah, we didn't get into programming because like, oh, we want to like maximize social utility or, we want to make sure the boss meets the deadline or whatever. Like that's not what's not why I got into programming in the first place. I got into it because it's awesome. It's a creative outlet for me. And, I get to work on, you feel like a mathematician and an artist at the same time. Um, and then this sort of feeling of flow and like being able to just create whatever you want and invoke these magic spells that make things happen.
So is it
And
a fair objective for you to create uh, this kind of flow in other programmers? Is are reports from other programmers experiencing this kind of thing the kind of success that you're after?
yeah, definitely. And I think that we're already seeing that with Unison. People report that they could never go back to traditional programming languages because the experience of writing these kinds of systems in Unison is just so much more pleasant. And I'd say even writing simple programs even is more pleasant because like there's no build, there's you don't have like this dependency hell, um,
Okay.
and all kinds of things like that.
Yeah, because I saw that in Unison, if you want to depend on something, it's a static artifact of sorts, but it's just a code hash. And if you want to use that, you can use it, and it's immutable. It never breaks anything unless it. I mean, if the type checker doesn't work, then it doesn't work. It doesn't compile. So
Yeah, that's right. So in Unison, your dependencies are as granular as possible. So that means that when you're using some function in your code that you got from a library or something, you have the hash of that function in your code. And so you're depending on a specific hash. And that hash encodes both the implementation of that function and the implementations of all of its dependencies. And so the dependency management is sort of like done for you.
mhm.
If you have another function in your library or in your program that's using the same function or like a different version of the same function, there's no conflict there. That is just a different hash and it depends on a totally different like dependency tree. And that's totally fine. They can live at the same time in the same code base. And like if they have different types, then normally you'll get like, I don't know, you get a dependency conflict, right? Normally. If it's like one type is like depending on a different version of another type, then like you try to reconcile these types, but actually, oh, there's this part of this record has a a type that has two different versions, and these two things don't agree on what that is, and you're going to get like a dependency conflict.
Okay, so
But in Unison, you just get a normal type error. You just say
okay.
like, oh, these types aren't the same.
I just wanted to
But you can
ask.
use them both.
Yeah, so you get dependency conflict in the form of a type checker error.
Yeah, essentially, you get a dependency conflict essentially in the form of a type checker error, and you can resolve that dependency conflict in programming. So you could just write, it's like, oh, okay, well, this thing requires an additional parameter that I don't have, but it's optional. So I'm just going to pass none, and then you're done, right? You don't have to go into, what is it called? SBT
Mm-hmm.
or,
To explore the dependency tree and trying to.
cabal. Yeah, exactly. You don't have to go and figure out how your dependencies are messed up. You could just write a function to convert between the two and move on.
Interesting. I'm going to try it out. Because I'm guessing that if your code base becomes significant, you're probably going to get into this sort of dependency conflict or type errors. And the question is, how do you mitigate or resolve that in significant code bases without bending over backwards to understand where those dependencies came from, which is usually the case in significant code bases in traditional languages. So, for example, if you break a thing in Scala or in SBT, you have to figure out where those libraries came from, and you have to kind of reconcile library versions so that everything fits. I'm
Yeah.
wondering how that process works in Unison.
Well, you're it's a trade-off. You're trading one set of solutions for a different set of solutions. So like in Scala, the solution is often like, well, to state the problem, it's like, you actually want to use, it's a big code base and you want to use lots of different libraries,
Mm-hmm.
right? But since it's a big code base, you may end up with parts of that code base that, have dependencies on different things that don't necessarily agree.
Okay.
And so in Scala, for instance, the traditional solution to that is like minimize your dependencies. Like, oh, we should try to have as few dependencies as possible, for one thing. And the other thing is like, we should make sure that everything that gets compiled together agrees 100% on what version of everything we're using. And then like, oh, if I'm depending on a library that disagrees, I need to know. I need to contact the author of that library and ask them to upgrade, or I need to fork it and manage that myself, right? So that could get pretty hairy. So in Unison, if you have a similarly large code base, you could have lots of different parts of your code base that don't agree on like versions of dependencies. And so the trade-off there is that you may end up with uh little sort of fiefs
Mm-hmm.
in your code base where you have like these sort of dependency clusters where like this subsystem over here has its own little dependencies, and you got another subsystem over there that has you know uh, different versions of those same dependencies. They can all still operate, but when you try to make them interoperate, you might get type errors. You might have to write some shims and stuff. Uh, but the upside there is that so the downside is it could get kind of complicated. The upside is that you can manage this as you see fit, right? You're not forced to go and talk to the library author or to fork the library or whatever. You can migrate at your own pace,
I see. So
or you can not migrate at all if you want to.
if you don't care, you just keep the independent systems work on their own dependency trees, and for that one bit where they interact, you can just do a conversion function or whatever gets the types in check. Is that it?
Yeah, essentially.
Okay,
Yeah,
interesting.
that's a much more concise way of saying that than what I just said.
Okay, I'm going to try it out. I mean, I'm very curious to see what kind of experience Unison is. I haven't tried it on a real thing before, but that made me very curious. I'm also curious. You said so. I would like to talk about many things that you're passionate about, and Unison obviously is the core thing of what you're working on right now. I wanted to also dive into your background a bit because you said that one of the reasons that you got into programming was a feeling of flow, of feeling like a mathematician and an artist at the same time, because programming is an inherently creative work. Um,
Yeah.
so, so I wondered how that factored in the choices that you've made in your career. So obviously, you spent a lot of time in the Scala world. How did that come to be?
How did I get into Scala?
Mm-hmm.
Uh, well, I guess I will. I'm sort of an enterprise Java refugee,
Okay, same here.
and yeah, so I got into Java. I mean, in much the same way that everybody got into Java. It was the late '90s, and it was the technology that everyone was building on. I joined a startup, and they were using Java and Smalltalk at the same time. And you know, I had never used Java before, but I liked it a lot. My background was in Pascal and C, and so Java was a very natural language to
Mm-hmm.
work in. Um, did like enterprise Java with enterprise Java beans and like Oracle enterprise components,
Yeah, I worked at
whatever
Oracle
those
for
things
two
are
years.
called.
Yeah, I know. Yeah.
Yeah, yeah. So I did that kind of stuff. Uh, and I remember one day we had a big complicated system, and we were having a meeting about like, well, how can we reduce the number of bugs that we have?
Mm-hmm.
Because like it's killing us. And a person who not even very technical said, well, is there a language you can use where like making bugs like this is more difficult?
Mm.
And I was like, huh, I hadn't even thought of that. And so I did some research, and I come to think of it that there's like this whole world of like verified programming, dependent types, and I came across Haskell and functional programming, and there was this idea that in Haskell that if it compiles then it works.
That's the promise of a strong type system, essentially, right?
Well, yeah, and so I came across these much stronger type systems than Java has. Uh, Things are a lot less forgiving. I also had some experience with Lisp, and so this was a very new thing for me to come to these very strongly typed languages.
Did you come, as an aside, did you move towards strong types as a reaction to Lisp being so so loose?
No, no, I do and always have loved Lisp. There's a soft spot in my heart for Lisp
Okay.
and Smalltalk as well. Even though they're very loosely,
Mm-hmm.
they're like monotyped, but they're fun things to work in until they're not, like until you have a large enough system.
Yeah.
But for small things, they're super great. Uh, so yeah, coming into functional programming, it was sort of like, the scales fell off my eyes. You know,
You
I
see the light now.
yeah, I saw the light in that I had always kind of thought about systems in this way. Other people thought about things in terms of like objects and how objects are interacting. But I always thought about, okay, well, I want to think about things in terms of functions. Like what is the data coming in? What is the data you want out? And how do they compose? So
Mm-hmm.
I thought about things in terms of these sort of pipelines more than like object interactions. And so it was a natural kind of fit for me to think about functional programming. And I got into a language called Clean. That was my first functional programming language. Clean was really great. Made some little games and stuff in that. And then uh, used Haskell in production at this Java shop that I was working at. Um, and then we experimented with functional programming in Java. So there was a library called Java Functional Java. I think it was called Functional Java. but that allowed you to do essentially functional programming in Java.
Like
And
function
then
objects,
somebody, yeah, function objects. I mean, this was before.
Java 8.
This was like, yeah, this is Java 6, right?
Mm-hmm.
So we were doing like there was a class called F, and it had
Mm-hmm.
a single method on it called apply, and so and it was parameterized with two types, the input type and the output
Mm-hmm.
type, and that was our function, and it was super great. It allowed us to simplify lots of systems really quickly. And then somebody suggested, well, why don't we just use Scala? So I was like, Scala, what's that? And so we looked into that. And it turned out that, yeah, we could just use Scala because it runs on the JVM. It interoperates pretty well with the stuff that we already had. Um, and 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 then that was in Scala, and it was great.
How much time did you spend writing Scala?
Much time did I spend writing Scala? Let's say I got into Scala, I want to say around 2006.
Mm-hmm. That was
And
around Scala 1.0 at the time.
yes, yeah, it was a brand new language at the time. And yeah, we I joined Unison in 2018,
Mm-hmm.
and so I was doing Scala all the way up until then. No, actually after that as well, because we
Yeah, because
wrote
you.
the initial compiler in Scala.
What made you move the runtime to Haskell? What kind of guarantees did Haskell give you that Scala could not, or what was the advantage of using Haskell there?
Yeah, calls. Like it's really that simple, I think. The the JVM doesn't have tail calls. And
Okay.
so there is always when you're doing functional programming on the JVM, there is always this thing hanging over your head, which is the call stack.
Mm-hmm.
And so at some point, your call stack is going to get so deep that your program is just going to crash.
And
And so then you need to resort to things like trampolines or free monads or whatever. And we just we would prefer to not do that. And so we moved to a language that actually does tail calls, where we can make the runtime do whatever we want.
Mm-hmm. And was a call stack a fundamental limitation even without the recursive aspect of it? Because Scala obviously has this tail call optimization, and I'm guessing that was not enough.
That's definitely not enough.
Mm-hmm.
Yeah, so Scala does have this tail call elimination with self-recursive functions, right? If you call a function
Mm-hmm.
at the end of itself, it will
Compile to loops essentially.
yes, it will turn into a while loop.
Mm-hmm.
But say you have a big list of functions, and you want to say compose all these functions, turn them into a pipeline,
Right.
right? If that pipeline is one too deep, you're going to blow the stack.
Yeah, that's fair. Was an effect system not an option for you? Or what were these too complicated, like the stuff of, I don't know, Cat's effect and things? Because they kind of do the sort of um, composition of programs and they run them sequentially without necessarily relying on the stack. So they put everything, all the programs on the heap, and then they evaluate all these mini programs, and you can compose them as you like. Was this not an option for you?
Uh, I mean, it was in the beginning. That's what we did. Uh, but no, it's too slow. It's too unwieldy. Um, so we want it to be a little closer to the
And
metal,
ditch the JVM.
which is the JVM. Yeah.
Got it.
We also just there's no reason for us to be on the JVM. We didn't have any aspirations of like interoping with Java
Mm-hmm.
or Scala. Uh, there was no uh, there was no like Javaness to this at all.
Okay. How does Unison solve this tendency from. So I want to ask about Unison in the cloud. Obviously, Unison is made for distributed systems, and obviously uh, you can deploy very easily on public clouds like AWS and stuff. Um, but I've seen, at least in recent year or two, a a tendency from various companies to go in one of two directions, either from the cloud to on-prem or from on-prem to the cloud. How does Unison address these two tendencies? Are you just focusing on the cloud, or are you also trying to address the on-prem thing? So being able to deploy your program on your own infra.
We're trying to address both, actually. The simplest solution that you could use is you use our hosted solution. So you basically run your code on Unison Cloud.
Mm-hmm.
The second, the second simplest solution is that you run it in your AWS, or in your cloud infrastructure.
Mm-hmm.
And then, we essentially just run like the control plane, so it's essentially transparent to you, like that you can use the Unison Cloud libraries and still like deploy on your own infra, in at a cloud provider. And then the third solution is you run it on your own hardware, in which case, we basically just give you the software and you install it, and you manage it yourself. But either way, you can simplify a lot of things when the only software you need to be running is Unison. So instead of running, you know, lots of these different tools, you run these Unison nodes.
Okay. Um, why did you make Unison uh, a typed language? In the sense that if you wanted to, so I'm guessing that a potential design for Unison could have been something along the lines of create functions, create hashes, and then refer to hashes. If those hashes don't exist, or if if the functions throw an error or something like that, then the program crashes. So for all intents and purposes, Unison could have been made a loosely typed language. Why pick it?
Yeah, that's true.
Why make it a strongly typed language?
I mean, mainly because we like working in strongly typed languages. Uh, I just find it really difficult to think about systems, in particular, you know, large distributed systems in an untyped language.
And why do you
And
think? Okay, go ahead.
well, you'll end up with other issues like, like you want things like you want type errors, for instance. Like you want the ability for the compiler to guide you towards like the correct type of something. In particular, if you have like lots of different versions of some type, you don't know that they're the same except like they have a different hash. And then, what are you going to do? You're going to walk manually over the code and like figure out where they differ? Well, you could just have the machine tell you exactly where they differ.
That's nice. I think that was a good decision, especially in distributed systems. It's hard to reason about code, especially if that code is loosely typed. So, as a typed functional programming advocate myself, I commend you for this choice.
Well, thank you, Sarah.
Why
But
do
I
you?
mean, no hate on, Lisp or Smalltalk or, other languages that I love. But I wouldn't want to write large distributed systems in those languages. That I just don't have the brain capacity for that.
I would tend to agree. Why do you think the functional programming aspect is important? Because Unison has the FP principles baked in. Why do you think those principles are important? And I'm asking in a general sense, not necessarily strictly related to Unison. Why do you think?
Well, I want to answer strictly related to Unison first, because this would actually be completely impossible without purely functional programming. Because when you're sending code over the network, you need to know what are the side effects that this thing could have.
Mm-hmm.
Am I closing over a file handle and like reading from it? That's not going to work. So yeah, it would be completely impossible to know that my code is safe to send over the network and run somewhere else, or that it's even going to work at the other end, right?
Okay.
So functional programming is essential to this. It would just not work without it. But then more in general, uh, it is just nicer to work in. Right? Functional programming it makes for a more pleasant programming experience. Uh, I think that you end up having a lot less of this sort of spaghetti code, um, and it reduces the design space of your systems. Like you end up having to think of things in terms of functions, so you're not you know thinking so much in terms of like, well, you know what responsibilities do these objects have over here? So I'm like comparing with, say, object-oriented programming.
Mm-hmm.
Um, and so there you have to think about like, oh, well, these two systems over here, are they really two systems, or could they be combined into one system? Like, are the responsibilities between these two systems overlapping somehow? Is this thing overstepping its bounds? Um, the surface area of all of that is just reduced a lot, I think, in functional programming, because you end up thinking in terms of functions and data types.
What kind of concepts do you think that would transfer well from Scala to Unison? I'm asking this for my audience, who are mostly at the time we're recording this 99% Scala programmers or aspiring Scala programmers. So I'm asking for them primarily.
Right. So what concepts would transfer for well? I mean, like, give me an example of what you would like to transfer.
So, for example, the uh, okay, a very simple thing is the ability to pass a function as an argument, return a function as a result, and then compose functions. That's a very basic thing that you find in all functional languages. Um,
Oh yeah.
Anything else? For example, in type signatures, in um, I don't know, the idea of generics or no or type parameters. How do
Yep.
those transfer from Scala to Unison, or what kind of main things you see from? So you're a master of both of these languages. You can pick whichever you want, but I'm guessing that there are some main ideas that if for somebody who knows Scala, they can very easily learn Unison if they followed fill in the blank principle.
Yeah. Okay. Yeah. No, I see what you're getting at. Yeah. So, for example, Unison is a strictly evaluated language, just like Scala.
Mm-hmm.
So it's not like a lazily evaluated language like Haskell. So it doesn't have that. So it's a much more familiar paradigm, I think, to somebody coming from Scala. Uh, we got generics just like Scala. We have higher kind of types just like Scala. So you can abstract over type constructors and pass
Mm-hmm.
them. But instead of putting them in pointy brackets, you just put spaces around them.
Okay.
Um, the
Pattern matching.
syntax looks very similar to Haskell. Uh, but yeah, we got pattern matching. Uh, and you'll be familiar with most of that if you're coming from Scala. You got this sort of at patterns, you got the deconstructing
Mm-hmm.
patterns for matching things as deep as you like. Uh, yeah, first
Algebraic
pass
data
functions, you
types.
got lists. Yeah, algebraic data types, exactly. So instead of traits and case classes, you just say type so and so equals, and then you list the cases essentially.
Mm-hmm.
Um, and you got familiar functions on everything that you're used to, like map and flat map and filter and fold
Okay.
and whatnot.
Would you consider a similar red book, but for Unison instead?
Yeah, we've considered it, but I would say at the moment, uh, like investing the time in writing a book like that would not be a good choice because Unison is changing fairly rapidly at this point. And so, and that book will be obsolete maybe in 5 years. It's just hard to know because it's a young language. The the syntax is changing as well as like the libraries are stabilizing. Uh, but that is another thing, which is, you know, we can change the syntax of Unison without actually breaking anyone's code,
I
which is
wanted to ask
another,
about that. How does that work?
yeah. Okay, so the code isn't text. And so this goes back to Unison's roots, where Unison was originally the sort of structured programming language. And so the reason why we can change the syntax and not break anyone's code is that the syntax is a purely user interface concern. So the code is actually stored as, yeah,
ASTs?
it's stored compiled. Yeah, it's
Hmm.
stored as the compiled AST. And then when you actually look at the code, it's decompiled and presented to you as text.
Okay, so if you change the okay, let me get this straight. So let's say you have Unison version 2025, April 24. The we're recording this right now. You
Right.
write a bunch of code. You have, I don't know, list.filter 123 map underscore plus one or whatever that is. Okay.
Sure.
You wait you wait 5 years, and then you have Unison version April 24, 2029 or 2030. Okay, assuming I can do basic math. Um,
Sure.
and
And let's
then
let's say we decided that the syntax should be S expressions. It should look like Lisp
okay, and you've
or
decided
Scheme.
okay, and then when you refer to that hash, it shows you back the interface with the new syntax directly because the AST is already stored in there, and then you can use the new syntax in Unison without changing any sort of code. Am I getting this right?
Yes, that's right. So your code will automatically get the new syntax because the syntax is purely surface level. Your code is never stored in text. So you work with it in text. You got your little the experience of writing Unison is that you have your editor, your buffer. When you save that buffer, the Unison compiler is watching and it will compile your code. And then you can say, okay, well, you want to add this to my code base, or you don't have to. But once you've added it to your code base, it's there, it's compiled, it's referred to by hash, and you can reference it in your code. But you can take that buffer that you wrote the code in, and you can delete its contents, and you'll never have to think about that again. So
Wow.
the way I work, actually, I just have one file that I do all of my Unison coding in. Just call it scratch.u. And
I've
so
seen
I'm just
you.
always working at the top of that file, and my code from before is just always being pushed down and down and down until it
Wow.
gets so long that VI can no longer handle it, and then I save it to a backup file, and I start with a fresh one. And so I have my full history of my Unison programming, uh, saved on my partition,
This is such a
and it's not
different
just
way.
syntax;
Yeah.
it's also names. So I'm working in the base library. I was just looking at, like yesterday, I was just looking at a type. It's called GUID, so globally unique identifier.
Mm-hmm.
And I said, well, we're not Microsoft. This should be called UUID.
Mm-hmm.
Okay, this would be a big deal in the Scala standard library, right?
Yeah, because
If
you
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 wanted to
break everybody's
change,
code. Yeah.
you
There's a new
break
type.
everyone's code. Anyone who uses this type would have to change their code. But in Unison, I just renamed it and pushed and did a release, and you're done. So when the next time somebody pulls base, their GUIDs are going to be called the UUID.
And they're gonna see it directly. No changes necessary to the code. That's insane.
No changes.
Awesome. Okay. This is something that's worth trying out, guys. Even just to experience this sort of thing. That I mean, as programmers, even with just a couple of years of experience, you get accustomed to a certain set of sources of happiness and sources of unhappiness, and you kind of take them for granted. This code
Yeah.
breakage is definitely one of them. And just to see a different style or a different way of approaching that thing, it kind of opens your eyes to the degree that you may or may not want to go back. And that was an eye opener for me when I learned Scala. I followed a very similar journey to you. I'm still in the Scala world, but Unison seems very promising for this reason because it kind of opens your mind to different styles of writing your code and different styles of thinking and approaching this, which makes it fascinating.
Yeah, I would recommend to anyone to like look at different languages, like learning Smalltalk really opened my eyes to different ways of doing things. Learning learning Scala and Haskell and Clean, you know, they they give you a different idea, and like things that you took for granted that were impossible or very difficult suddenly become easy. Uh, and then things that you took for granted that were like annoying or a source of pain for you, you learn that they don't actually need to exist at
Hmm.
all. But yeah.
What kind of okay? So small talk, clean, Scala. Any other things that you would recommend for, especially for the beginner programmers getting into the industry, just to broaden their mind? What kind of languages or tools would you recommend they learn, even just to broaden their perspective?
I mean, obviously, I'd recommend Unison to broaden their perspective.
Okay.
I think I happen to think Unison is a very approachable language. We have a growing and friendly community. People are very helpful. We have excellent documentation for most everything. The documentation is written in Unison. We have a way of contributing. If you like see a thing you want to improve, or find a bug in like a typo in the docs or something, and you want to like test contributing, it's super easy. Like there's almost no barrier to contributing to things. And yeah, I would also recommend people check out Haskell, because that is, it's a good sort of prototypical functional programming language.
It seems to be
And
foundational.
it does, yeah, I mean, it's the outcome of like many years of research, and it was sort of meant to be this sort of foundational functional programming language. Like what would it mean if we took functional programming seriously? And Haskell was the result.
Why do you think Haskell is not so popular? I mean, Haskell is a pretty niche language. Why do you think that is, given that it's so foundational that pretty much everybody needs to know? And many Scala programmers do have this Haskell background. Most of the critical contributors to the complex frameworks of Scala, including effect systems and stuff, they're borderline mathematicians with Haskell backgrounds, and they've suddenly found Scala as an avenue to make Haskell production like. But why is Haskell itself not that popular? Do you have any suppositions there?
Yeah, I don't know. I mean, I think that Haskell still has this air of being like a very serious language, and it being kind of like a research language. You know, like people have this sense that Haskell is not for production. Uh, but which I think it may have been warranted in the past, but it's certainly not warranted anymore.
I mean, you're writing a distributed system in it, so yeah, seems to be
Yeah,
worthy.
I mean, yeah, we're using Haskell in production. It's great. I mean, we're also using Unison in production, so yeah. Some people say like, oh, the syntax is weird, and that's why it's not popular. But it's not that weird. Like Smalltalk had weird syntax, and it was pretty popular in its heyday. That was Smalltalk was the lingua franca of object-oriented programming until
Hmm.
Java came along.
Yeah,
Um, I mean, there was C++, which was also very popular. But I mean, C had a weird syntax
C,
in its
C
time.
still has a weird syntax, and C++ even
C
more
still has a
so.
weird syntax. Yeah, yeah. But so I don't think it's the syntax. Uh, but I think it's also that it's lazily evaluated. So, it's a lazy language. So it's kind of weird, like the way it works.
Hmm.
Um, and I think that also makes it easy to shoot yourself in the foot. You might have like the program might not work the way you expect it because like laziness changes the way things work.
Hmm.
Uh, but I don't know. What do you think? Why is Haskell not more
No
popular?
idea. I mean, I tend to think that. So, okay, having spent enough time in the Scala world, Scala has garnered. I mean, not everybody, but quite a bunch of people have this idea of Scala being a complicated language, which is really not the case because you can get very productive with Scala very quickly. So after you learn, if you come from Java, Scala is very, very easy to pick up, and then you can
Yeah, it's like
create.
one for one
Yeah,
translate from Java.
right. But then if you try to get into one of the more complex frameworks like the FX systems or Akka or whatever that is, there is this Haskell-like vibe to it that you have to know the concepts of like monad and monoid and applicatives and whatever mathematical concepts were translated from category theory to functional programming and stuff. And this probably gets the allure of Scala and those respective frameworks being elitist to a degree. And I'm guessing this allure is um, attributed to Haskell as well. This is my supposition.
Yeah, there's probably something to that. It's
And
for the elite, it's for the priests in the ivory tower. It's
but
not
then
for the
when you
programmers in the
become
trenches.
experienced, when you become knowledgeable of the tools, so a Cat's Effect experienced developer can really build
Yeah.
anything. I mean, and you have the type system working for you, and you have these guarantees, and then you have this amazing expressive power that you can then use to its maximum productive ability, and you can build very complicated systems very quickly with this knowledge. But there is a learning curve to that you have to cross, and once you cross it, then you can build anything. I'm guessing again, this is probably true for Haskell for any
This is
productive
true for anything. This is true for absolutely anything. Like, I don't know, like take, I don't know, whatever. Something that people use all the time, like
Python.
Kubernetes.
Okay,
Yeah,
Kubernetes.
Python. Okay, yeah, but take Kubernetes, for instance. There's a learning curve to Kubernetes. There are concepts you have to learn. There are things you have to come to grips with if you want to be productive and build like whatever systems it is that you want. There's a whole language of it that you need to start to speak. But this doesn't seem to be an impediment, and I'm wondering what it is about some technologies or languages in particular that make people, or I guess libraries also, that make people reluctant to engage with it because it seems there's stuff to learn. But that's true for everything.
Yeah, it's fundamentally a mystery to me. The only thing that I can come up with is a story or a supposition or a theory, but I don't have the data to back this up because even my own students, so I try to flatten that learning curve as much as possible, and even for a complex system like Cat's Effect and the category theory, playfully known as CATS in Scala, people learn that in a week. And after that, they build like streaming services and stuff. So, what is it that scares people away? I'm not sure. There is probably also the mimetic aspect of it because we programmers tend to talk a lot in between
Oh yeah,
ourselves.
sure. Well, I
And
mean, my working hypothesis is that it's a market thing. Like people know that they're in the market for Spark or
mhm,
Kubernetes or whatever, but they don't necessarily know that they're in the market for Haskell
mhm,
or Unison or functional programming because there is, even though if they knew about it and if they tried it, they would love it, and they couldn't imagine living without it. They don't know that this is a thing that they're in the market for, right?
Yeah. Yeah, I mean, there's also the jobs perspective, uh,
Oh,
because
yeah. I mean,
because
there's
people,
lots and lots of Haskell jobs out there. And Haskell programmers are hard to find.
yeah, that's interesting. I didn't know that. I'm not familiar with the job market of Haskell, but it's uh, it's surprising to hear that. That's interesting.
Well, I mean, maybe the reason why, you know, they're hard to find is that there aren't that many. And
Yeah, I mean, this is a similar conundrum in Scala as well. There is a vicious circle of companies claiming that they cannot find experienced Scala developers, and then Scala developers claiming that there are few jobs. Something has
yeah,
to something has to be off here because they cannot both be true. And
no.
especially in
But I
the
also think that the onus falls on the companies. It's like you should expect some level of training your programmers, right?
yes,
Because even just coming into a fresh code base, there's all these concepts and like the language of your workplace that they don't speak, right?
yeah, that's a very important point because it's not just the programming language or tool that you have to learn. It's the conceptual framework of your product or your team
Right.
or your company that you also have to get accustomed to, which is a similar learning curve to learning any sort of tool. How do you?
But I think learning a programming language, if you're already a programmer, learning a new programming language is very easy
Yeah.
compared to learning like the language of a new workplace, even if you've already worked somewhere else.
How do you plan on breaking that barrier with Unison? If you want to make, do you want to make Unison a mainstream language, or are you comfortable in having it very specialized for a specific set of distributed systems job? And if so, if you want to make it a mainstream language, how do you intend to cross that gap? Because you're probably going to have to cross a chasm between Unison being a very nice, very powerful language and then getting the market for it so that it can justify the marketing to other programmers.
Yeah, I mean, we definitely obviously want people to use Unison and to enjoy using Unison. We want to grow our community and we want more people to be familiar with the idea that Unison is a good language to work in. But mainstream, it's like how do you become mainstream? The problem with the mainstream is that like it's not a stream. It is a stagnant swamp. And you don't if you try to like go mainstream, you're gonna end up just like sinking into that swamp.
So
And
you
so rather want to pull people out, of the mainstream to move forward.
okay? So you think that it's going to kill the dynamism of Unison if it becomes very well known because it has to support many things or many use
There's
cases or
probably something there's probably something to that, but that's not what I mean. What I mean is that we don't want to like betray our uh, values. We don't want to tailor Unison to so that it's more familiar or like sacrifice some of these
mm-hmm.
niceties just to have it be more popular. Because in that case, people can just use Scala or Java or whatever. There are already languages for that, and so we don't want to be like that. So
How is I have to ask about this. How is AI or LLMs? How are they familiar with Unison, and how what's the experience like of LLM assistance with Unison?
it's become a lot better. So back when GPT-3 was and like 3.5 were around, and when Copilot first came out, they were very unfamiliar with Unison, and they would
Mm-hmm.
just basically write Haskell
Mm-hmm.
instead. And there was no way to tell them, um, except you could have just a bunch of code in your Scratch file, and then Copilot would pick up on the idea, right? So if
Okay.
you had a lot of Unison code in your Scratch file, which I normally do,
Hmm.
then like Copilot would figure out that this, like, what is the syntax of the language that you're working in? But there's a lot more Unison code out there now, and so I think that the LLMs are becoming more familiar with it. I can have an intelligent conversation with like
Hmm.
GPT-4 about Unison, and it'll not say things that are completely untrue like it used to. Uh, and it can generate like passable Unison code. It will sometimes forget that like let doesn't require in,
Hmm.
or like little syntactic things that I sometimes forget too. But yeah, I can you can now go cold basically into GPT-4 and say like, oh, can you write a function for me in Unison that does this? And it's mostly correct.
Do you use AI assisted code just for your own work?
Absolutely. Yes.
Okay.
I use it to write, to fill in things mostly.
Hmm.
So like I'm pattern matching on some data structure, I just drop, say case,
Hmm.
cases, and then I
Tab.
drop it to the next line and it fills in the cases for me.
Hmm.
That's amazing. Or it will, I write one case and it will pick up on the idea and then write the rest of the cases. Um,
How
we
should
could
people?
write documentation.
Okay.
Yeah.
How should people think of LLM assistance in programming? I'm seeing this whole current of vibe coding and stuff. I wonder how you think about it.
So I tried it. I tried vibe coding.
Hmm.
I tried vibe coding in JavaScript. So I wanted to make sure that the LLM was very familiar with the language. So I wanted to make a very simple, like dynamic web page in JavaScript. And the experience was terrible. Like
Okay.
currently I think the current tools for this are just very primitive.
Hmm.
And so it'll do things like forget what it's doing. It will, delete code that it wrote before for no reason. Uh, and basically just like keep clobbering its own work. And like no matter how often you tell it, like,
Don't change anything.
you know,
Don't change
yeah, or
anything
you
about
tell it
it.
don't change anything. You tell it, oh, this stuff goes in this file over here, or whatever. It's like, oh, put the CSS in the CSS file. And it's like, no, no, I'm gonna do style tags. Um, and no matter how often you you tell it, like even if it's just made a mistake and you point out the mistake, and it's like, oh yeah, yeah, my bad, let me fix it. But it doesn't fix
Hmm.
it. So it's bad. But for the way I like to think of it is just as you know, as somebody sitting, like a junior programmer sitting with you, and you're pair programming basically. So I like to have I use Cursor at the moment. So I like to have it, filling things in for me. So like, oh, I hand the keyboard over to Cursor. Or, I, highlight some code and I say like, ask, can we make this better? Or is this uh, can we change this so that it does this and this and this? And just like sort of chat with it.
Hmm.
Generate ideas, uh, like a rubber duck, except the rubber duck can talk back to you.
Hmm. And then you can pick the best of what it says or it gives back.
Yeah, or just completely ignore it. Uh,
Or yeah.
sometimes that's the best thing. It's like you just need to say things out loud and get some feedback. I mean, you can bother your coworkers about that and stuff, but it's a different way of working where you essentially have this sort of intelligent autocomplete or more intelligent autocomplete where you can complete like entire functions or fill in things that are tedious to write.
Yeah.
Or, you know, I have a whole bunch of Unison code in my Scratch file. It's all nicely documented. And then I write another function and I can just, Command K and say, write the docs for this function,
Hmm.
and it will fill it in.
That's nice. So it's kind of fulfilling the job that it was supposed to, which is essentially do the tedious work.
Yeah, do tedious work for it.
Yeah.
But it's not always just the tedious work. It's sometimes generating
Maybe
ideas.
ideas, new ideas, or maybe you can ask it, "Hey, where am I missing?" And they can actually point something out that is actually useful.
Yeah, that's true.
What would you tell a prospective software engineer just coming into the industry right now, um, with all the tools and with all the programming languages and with all the AIs that we have at our disposal? What would you tell them? How would you guide them to learn to be a good programmer and get good taste in software, which is this intuitive approach to what good code is and what it's not? What would you tell
Yeah.
them? What would you direct them to? What kind of programming languages would you advise them to learn? What kind of books to read? What kind of people to follow? Any advice?
Oh man, big question. I mean, I don't know.
What would you tell yourself? I mean, assume you're starting right now.
Yeah.
You don't know anything. I mean, you don't have all your Scala and Unison and anything. You haven't built anything, but you do have your wisdom and your first principles. So the question is, what do you learn? What do you get started with?
Right. I mean, people always have this tendency to say like, well, follow in my footsteps, do exactly the things that I did and you'll be fine. But I don't think that's necessarily true. Like there's a lot of, you know, detours and stuff and
Hmm.
hurdles. But I think also maybe overcoming those hurdles is part of the learning experience. Um, but I don't know, the things that I found most helpful in my journey, becoming a software engineer were, for example, good books.
Hmm.
So I think books tend to get overlooked, but a really good book that's like crunchy, that has like really good, you know, has like code in it and
Hmm.
isn't like vague in general. So, it's got some crunch to it. A really good book like that can go a really long way.
Any
Things
examples
with
that you found? I don't know. Relatively timeless. I mean, the industry changes a lot, and some books get outdated, but things that you believe are foundational books.
well, okay, so structure and interpretation of computer programs
Hmm.
I found absolutely amazing. At least the first few chapters until they start talking about mutable state, where I kind of lost interest. But I think that's a really good book. I don't know if that's a good book to start with, but it's awesome. Uh, there there are two books by Paul Hudak called The Haskell School of Expression and The Haskell School of Music.
Hmm.
And those I think are amazing because so the first one talks about generating it's a lot about generating art and like generating fractals and like expressing yourself with programming
Hmm.
uh and it's very crunchy. It's like it's got code. It teaches you how to write Haskell code, not assuming that you know anything already. And then Haskell School of Music is another one that where it teaches you how to talk about music and programming. um, which another very crunchy book. I mean, obviously there's functional programming in Scala,
Hmm.
which
The famous
we
red
tried to
book,
make that
people.
one as we tried to make that as crunchy as possible, where it's dense with like practical advice and also the programming exercises. Like getting your hands dirty, I think is the most important thing. Like, yeah, if I could give one piece of advice to aspiring software engineers, it's write code. Okay, just write code.
And don't let the LLM write the code for you, or not. Maybe not the entire thing.
Well, not all of it, uh, but definitely, yeah, definitely write the code. Think about writing code. Um, I mean, think about how you're going to structure the code and stuff. But if you're using a language model to like do some of the work for you or whatever, you should make sure you understand what it's doing. and like why it's doing things the way it's doing. Because I think a lot of LLMs have very poor taste. So you were talking about taste,
Yeah.
and so you may end up with you may end up learning bad habits from the LLM. But also like online tutorials are really great. There are lots of great programming tutorials for Scala and for Haskell. I went through the Clean book when I was learning
Hmm.
Clean. That was really awesome. Very crunchy, teaches you how to use the language with practical programming exercises. So, the thing I love is like when I'm learning a new language, it's like the creators of the language have made like this series of exercises, and if you when you go through them and you emerge knowing how to use the language for something,
That's nice.
fantastic.
Okay. So I think um, that's a good set of advice that everybody I think should take to heart. Do you have any idea of how people develop good taste? I've had this conversation with a few people, and uh, you generally hear about good taste from a master programmer who spent enough time in the industry or in this craft, and they develop good taste on their own terms. Do you have any idea of how to develop good taste? Or if not, and you can, and if the answer is just write your own code until you develop your own intuition, that's also a fine answer. I wonder what your take is on that.
I think writing your own code, yeah, until you develop an intuition for it, that is good. But you also have to see how other people write code. Uh, I think as you're writing more and more, as you're doing more and more programming, you come across libraries that are pleasant to use. You come across libraries that are unpleasant to use, and you start to sort of learn the difference.
Hmm.
And then when you're starting your own libraries or writing your own code, you you tend to, I think, incorporate some of those lessons. Like you think about how is this going to be used, and is it going to be pleasant to use? And then how can I maximize how nice this is to use? Like think about the end in the beginning. Think about the end. How how is this function going to be called? How is it going to be composed with other things? Is that going to be nice?
It seems that this has been the core of your journey with Unison as well, because you're not just making a library, you're making an entire ecosystem, an entire programming language and framework of sorts, so that you maximize the pleasant aspect or the pleasant part of programming. So I think that's a good
Yeah,
rounding
I
circle.
think that this is something that I've actually only recently come to terms with or come into, which is prioritizing, the pleasantness of using something
Hmm.
over like necessarily like correctness or robustness or whatever. Uh, like for example, I wrote a little HTTP routing library in Unison, and there are lots of different ways of doing this. But the thing I found that I wanted to optimize for was, is it nice to use?
Hmm.
And like I could have written it so that it's like very correct, and like the whole website the whole HTTP server is like encoded in the type. So I'm sure you've heard of libraries like that. For example, in Haskell,
Hmm.
you got there's a library called servant where like the entire server is encoded in the type, and like the type describes how the server behaves and how you're supposed to interact with it. But it's really, really difficult to.
Hmm.
It's
You
very
kind of fight with
unpleasant
the
to work
types.
with, I find. Yeah, well, yeah, there's some fighting with the types, but it's also just like that's not, that's not what I want when I'm writing something, when I'm writing an HTTP server. It's like once I'm at that point, I already don't super care about the types of things. So yeah, I found that instead of making things as correct as possible. I want it to be pleasant to work with. Because I think you find in the end that often you will have to move, like you'll have to move through invalid states in order to get between the valid states.
Hmm.
And like if you make that journey very difficult so that you can only move through valid states in order to get to another valid state, uh, you know, it becomes very unwieldy. It's like one of these little puzzles where, you have to like move a thing along a wire, but it can only move a certain way. It's
Hmm.
like, okay, if I could just pick it up and put it over here, it's gonna be correct in the end. But I don't have to move it through the correct states in order to get there.
This is so nice, and I think it's a good full circle conversation back to Unison as a pleasant to use experience for programmers. Um, Runar, I wanted to say that I appreciate you taking the time for this conversation. It's been a lot of fun, and time flew by for me. Is there
Yeah, for
anything
me
that,
too. I just realized.
yeah, is there anything that you would like to share with my audience before we wrap up? Maybe, I don't know, a piece of advice, a quip, uh, anything at all.
Put me on the spot. No, nothing I can think of. But definitely come join the Unison community and see what's going on there. Try it out. We're super friendly, and Unison is great to work with. So definitely come do that.
N-
And I don't know. One piece of advice: take your happiness seriously.
Nice, and have fun with your code, not just make a make a machine do things because obviously
Yeah,
that's
be careful not to become the machine.
yep, definitely second that. Runar, it's been a pleasure. Um, where can people find you?
Well, I'm on. Um, I'm in the Unison community, so come find me there.
Okay,
We have a Unison. There's a Discord server, so unison-lang.org. That's where I am. I'm also on Twitter. I'm Runar O Rama. I'm on GitHub, also under that handle. So yeah, I'm easy to get a hold of.
awesome. So we're going to leave all these links in the description, folks. Uh, do check out Unison, and until next time, thank you for watching.
Thank you, Daniel.